Hello and welcome to the Daily Space for today, January 15th, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. Now, we actually have more news than anticipated today. And once I started reading through the press releases, it all made sense why. We can thank the journal Nature Astronomy. They have a new issue coming out, and all the articles that were submitted however many months or sometimes years ago, they are now hitting publication. The press releases are hitting my inbox, and we have new information. So without further ado, I introduce you to a well-behaved black hole. Actually, several of them. In a press release coming to us from Israel, we have a black hole that has been found to do exactly what was predicted back in the 1980s. In this case, what was seen was this black hole and several similar ones, and this is an artist's rendition. This is not an actual black hole. This is not a photo or an image. This is art. So what was found using the Las Cumbres Observatory, using NASA satellites, using the NICER Observatory on board the International Space Station, was that several black holes located in the centers of galaxies were seen to periodically light up. Now, it wasn't the black hole itself that lit up. Black holes don't do that. That's just the shorthand that we use when we're communicating about them, which is a really bad shorthand. What's happening is material spiraling in towards the black hole got torn up, compressed, and in the process of not quite falling in, right before it fell in, as it was about to fall in, it gave off a massive amount of light across multiple colors that we can see with our eyes and that we can't see with our eyes. Astronomers from around the world and above the world observed this light coming off of these different black holes, light that lasted months at a time, and discovered in the process that these transient things that they observed behaved exactly as had been predicted back in the 1980s by Tel Aviv astronomer Professor Haggai Netzer. So Haggai Netzer, back in the 1980s, had predicted that a black hole swallowing gas would give off a particular spectrum, a particular pattern of colors of light, and that it would only do this temporarily. Now, exactly why gas will periodically, suddenly, and dramatically fall into a black hole, can't answer that. This was one of those cases of a theoretician saying, what if a chunk of gas suddenly opted to fall into a black hole? What would it look like before it met its end? He made predictions. And today, thanks to the many telescopes that we have constantly searching our sky for things that go flash, flare, and flicker in the night, there were cases of these systematic temporary brightenings of light being seen, being observed across many different wavelengths, and then going away. So this isn't a case of things suddenly turning on. This isn't a case of active galactic nuclei popping into existence before us. It's a case of a black hole eating something, which is cool. And it's cool to see that this researcher is still alive to see his theoretical predictions become reality. Now, in other cases of things that we thought could happen but didn't know if they would, astronomers using the Atacama Large Millimeter Array in Chile have confirmed the existence of a pair of stars tightly orbiting one another that are surrounded by a asteroid belt-sized disk of material that is going round and round in exactly the opposite orientation. So we have a situation where we have two stars that are going around like this, and as they go around, they don't have a disk of material in the same orientation. They instead, and my fingers won't let me do this, have a disk of material that is in the exact perpendicular orientation. We're still trying to figure out exactly how this kind of thing happens. Its angular momentum is a bit odd, but it happens. And that's cool. This tells us that there's really no limit to the insane pattern of things that might be possible in the sky. Now, if you want to know what the sky would look like if you happen to live on a planet on the inner edge of that asteroid belt, well, I'm doubting that the asteroid belt is actually a glowy disk in the sky. They don't come quite that dense, but that's how they look in the Atacama Large Millimeter Array images, so the artist took license. You would essentially see two stars that went in and out of the plane of the planets, and then you would see this plane of the ecliptic filled with rocks reflecting their sunlight, starlight. Now, what was particularly cool about this system, for me at least, is as they observed the system, they found that there were the two stars on the inner, there was the disk of asteroid-like debris in a protoplanetary disk perpendicular to that, and there's two more stars on the outskirts of this system out beyond the edge of that disk. This is a 4-star system. Now, this isn't to say that if you lived on one of those planets that may someday form in that disk that you'd see 4 stars rising and setting. In fact, if you went just as far as Pluto, our own sun starts to look no more interesting than Jupiter. I mean, it's a little bit more interesting, but it's still awful tiny and boring in the sky and just barely casts shadows. So it would be those inner 2 stars that really defined your day. But the fact that the system has 4 stars is still kind of cool. Today's really just a cool science kind of day. Things that don't fundamentally change our understanding of the universe, but science is incremental. Science moves one step at a time as observations allow us to know, well, what theories are true and which are not, and allow us to realize that sometimes our confined human imaginations aren't as creative as the universe in what they create. Turns out the universe knows no limits. Now, human creativity does sometimes allow us to do interesting things. In this case, I have 3 images and a photo. And by images, I mean images of paintings. These are paintings by astro artist and planetary science Dr. William Hartmann of my own institution, the Planetary Science Institute. He has, over the decades, done amazing painting after amazing painting of the things that science predicts to be out there somewhere among the stars. In this case, he has 3 different paintings, each depicting these, these conjoined asteroids, if you will, these frozen bodies that form these bilobate objects. And what's fascinating is in the lower right, we have 2014 MU-69, the object that New Horizons recently flew by, capturing that snowman image. And if you look, it has a bright neck, just as Bill Hartmann's artwork does. It has craters, very similar to the craters of his artwork. And its color is, in fact, partway between the colors of 2 of those different objects. So here we go with art is predicting science. but it's art that's motivated by science. It's pretty cool. The universe is kind of awesome when we get news. So thank you, Journal Nature, for having an issue that came out today, because as I talked about yesterday, it's a slow news week with so many different facilities shut down and so many people still recovering from last week's American Astronomical Society meeting, and it's just a quiet week. So that's all the news I've got, and I will now answer your questions from the chat. I saw a bunch of different stuff coming in. Space cows. Yes, Fenring, there are space cows. If none of you, if any of you don't know what I'm talking about, Mika McKinnon on Twitter did some amazing artwork explaining the physics of how you end up with these two Kuiper belt objects that merge ever so gently, and she used spherical cows in her illustrations. So backing up to see what all is in here. Scrolling up to the first place, I see a question. So Larry Weird and Proud is asking, can a black hole fuse iron nuclei in its accretion disk? It all depends on just how big, bad, and ongoing the nuclear fusion is in that accretion disk. There's nothing physically preventing it from being possible, but it starts to become a question of, would those kinds of nuclear reactions generate so much energy that it would push apart the accretion disk, thus slowing the reactions, lowering the temperature, dropping the pressure? This is a feedback system where if you generate too much heat, too much light, it expands the system out, preventing those high energy processes from taking place. So I'm not sure if we have any systems that are hot enough, dense enough, and ongoing long enough to get to that level of fusion. At least not the same mechanism that exists in stars that are 8 solar masses and larger. Let's see what else we have. Fenring is asking, can material near an event horizon get so hot and compressed that it can trigger fusion? Yes. Also, what causes polar jets? Magnetic fields. Let me explain that in more detail. If you have a black hole, we're going to call this frog a black hole, and you have a disk of material, in this case, a watch, that is going around it. What ends up happening is, if you have a single object that's trying to fall into the black hole, conservation of angular momentum, unless it's headed straight on, is going to cause it to spiral. As it spirals, it will get stretched out. It will end up frictionally interacting in all sorts of different ways with other material in that disk. So as this accretion disk has material struggling to lose angular momentum as it falls in, as everything interacts and builds up in this disk, getting bigger and bigger disk, eventually you'll hit the point where the disk itself has so much gravitational pressure vertical to the disk that it triggers nuclear reactions going on. Now, at the same time, all of this hot material, you end up with ions in the disk, and ions going in a circle, charged particles going in a circle, are essentially an electromagnet. Thank you so much, Hidden Faker, for the follow. Thank you. So when you have this disk of material going round and round that is charged material, it generates a magnetic field that has the North Pole going in the right-hand rule direction and then the South Pole going in the other direction. Particles that end up getting caught in that magnetic field then end up getting shot out, well, like something fired on a railgun, essentially. So let's see what else we have. Yes, Fenring, Mika's illustrations are absolutely amazing. So Gluten-Free Space is asking, would neutron star matter be stable in our terrestrial environment? If you had the entire neutron star, yes, but that would destroy our environment. The thing with neutron stars is they are allowed to exist at the amazingly high density they are at because they have so much mass, and that mass is gravitationally collapsing everything in so that the neutrons are as packed together in what's called a degenerate gas as is basically possible. Now, if you just grab a handful of neutron star using some means of science that doesn't exist and bring that small amount of neutron star material back to an Earth environment, first of all, it's going to break your hand because it weighs so much. But second of all, it's very quickly going to decay into other things because there's nothing forcing it to stay in that high pressure degenerate gas kind of format. And neutrons naturally aren't stable and prefer to decay into a proton and an electron and some energy. So what you'd essentially have is a fistful of stuff that goes boom and kills you. So don't grab handfuls of neutron stars and bring them back to Earth. Now, a neutron star itself is only in diameter about the size of Manhattan Island, about the size of a dense city core. So you could bring one back to Earth. It would just suck the entire Earth in and destroy it. So don't bring home a neutron star either, even if it does try and follow you. Anyways, that was a really bad joke. I'm going to move on quickly. So Kevlar is asking, are you more curious with New Horizons exploring beyond MU-69, or if possible, could she turn back toward ice giants? So the thing about New Horizons is it's on a trajectory and it has a ton of velocity in a direction that points it out of our solar system. And while it does have fuel on board, it doesn't have enough fuel to turn around and come back to the ice giants. It's gone. It can deviate its course a little bit, but not that much, just enough that hopefully we will find there are other Kuiper Belt objects out there that are generally along its current path. And it can make the small deviations in speed that would allow it to go a little bit to the left, a little bit to the right to see one of those objects. A good way to think about this is a human being on roller skates going down a massive mountain. We see videos of this on YouTube and they're terrifying. Well, these individuals using human power have the ability to turn a little bit to the left, turn a little bit to the right, not collide with one another, keep each other on the road. But they don't have the ability to turn around, cancel out all of that velocity, and go back up that mountain. They just kind of crash and burn and continue tumbling down the mountain in an uncontrolled manner. Well, New Horizons is kind of one of those roller skaters going down a mountain. It has its velocity, it's on its way out, and it can steer, but it can't go back. Let's see what other questions there are. I'm glad that you like this stream, Hidden Faker. Please stay. We do this every day. Every Monday through Friday. That's not a holiday. So Veronica Kier is asking, do you know what happens to all that energy consumed by a black hole? It makes the black hole bigger. Black holes are basically the things that vacuum clean up whatever comes near them and just keeps it locked inside, more or less. Black holes do evaporate. That's a different process. We've done Astronomy Cast episodes on that. So search on Astronomy Cast and you'll find 30 minutes discussing these kinds of topics. Yeah, Eddie has opinions. Eddie really has opinions out there. Sorry about that. Eddie is the dog you heard barking in the background. So Fenring is asking, but how does it get charged if it was neutral to begin with? When does imbalance of charge happen? So when you have all of this material in the accretion disk, it might start out as like neutral atoms where all of the electrons, all of the protons, all of the neutrons are happily in their atomic selves, just minding their own business, floating through a galaxy. And as they get too close to the black hole, they will have their orbits disrupted and they will get compacted into the accretion disk. And gas laws work within accretion disks. So some of you may remember perv-NERT, pressure times velocity equals the number density times the Rydberg constant times the temperature. As the pressure goes up, the temperature also goes up. And at a certain temperature, those atoms are like, I'm done with these electrons. These electrons can just go away. So in these extremely high density environments where the number is very high, the pressure is very high, temperature gets to be very high, and the volume actually goes down. So it's a perfect storm to just increase and increase the temperature in that gas. And that causes the electrons and the nuclei to, well, ionize apart. So the electrons are still there, the nuclei are still there. This is where you get this hot, excited, glowy gas. And some of those electrons are going to end up getting slammed away, causing all sorts of different things to happen. It's a cool, dynamic system that's actually very, very hot. So let's see what else we have in here. I hope I answered your question so that you finally understood. perv-NERT, yeah, Fenrig. It's one of those equations that you just never, ever forget. There's certain information that lives in my brain that just refuses to go away because I had to memorize it so hard for high school exams. We all have useless information in our brain. For me, the most useful single piece of information that my brain contains is the scientific name for fruit flies, which is Drophelia malangasker. I'm probably not pronouncing it correctly, but it's in my brain. So now you know. Anyways, do we have any more questions out there? As always, we are a production of the Planetary Science Institute working in collaboration with Youngstown State University. We bring you the Daily Space every Monday through Friday, most at least, at 1 p.m. Eastern. That's 10 a.m. Pacific, 6 p.m. London time. We are here to bring you a quick rundown of everything that's new in space and astronomy and to answer your questions as best we can. Now, that's not all we do here on CosmoQuest on Twitch. We also bring you spacecraft launches, landings, press conferences, office hours, and more. If you want to support what we do, well, please do, because we lost our NASA grant, and with the government shut down, we can't get a new grant and help. Every bit really matters. Every sub brings joy to our hearts, and you can also support us on Patreon and get benefits that aren't just emotes for what you give. So check us out over at patreon.com/CosmoQuestX and find out how you can become, well, a supporting cast member in everything we do. Thank you, Kay Moore. Thank you so much for the bits. Thank you. So are there any other questions out there? Oh, thank you, Trekker Kev. Thank you so much. So Larry is asking, where are you going Friday? This Friday, I'm going to be flying out to Boston, Massachusetts, my hometown. Thank you, Veronica Cure. Thank you so much. And I'm going to be attending the Aresia Science Fiction and Fantasy Convention at the Boston Park Plaza Hotel. You are all invited. I know it's short notice and there's snow expected, but hey, if you're in the area, come on by. I will be doing more panels. Thank you, Fenrig. Thank you so much for the donation. let's totally light up the chat with all the rockets, all of them. Thank you so much. Yes, it's the 100th anniversary of the Great Molasses Flood, in which people died by molasses. Google it. It's one of the stories that as soon as someone moves to Boston, someone pulls them aside and is like, have you heard of the Great Molasses Flood? And the poor newcomer is like, you're just making fun of me. You are just like pulling my leg. No, there was a molasses flood. Okay, so I will be at the Boston Park Plaza Hotel this weekend, giving all sorts of talks, moderating all sorts of panels on all things science, fiction, and television related. Come check it out. I will also be at the Broad Universe booth selling my own artwork and trying to bring in a living. So, Gluten-Free Space asks, since China is starting their new cotton industry on the moon and NASA is quite far in their Martian potato farming, what are your thoughts on space food? Do you think it's safe? As near as we can tell, once a plant is fine with growing in space, it's tasty goodness. There's actually been issues with astronauts like sneaking a bite of stuff up there from what I've read in a few places that are unconfirmed. All the research we've done on yeasts that have gone to space, on tomatoes that have gone to space, on all these different things, all of it is completely fine. The thing is, things don't like to grow normally in space. They don't like to seed normally in space. So we are going to have a challenge getting the multiple generations of crops that you need for sustained living, not on Earth. Everything likes gravity. We did a whole series on ways that different forms of life failed in space over on Astronomy Cast, so you can check those out. So Drop Bear Antics is saying, yeasts in space? Let's brew some space beer. That has been a thing. Let me see if I have the box. Hold on. Oh, I don't have it within reach. There was actually some really tasty beer called Ground Control that was brewed a few years ago using the yeast that had flown to space. Yeah, it was amazing. They haven't brewed it recently, but yes. So DPI 209, everything likes gravy too. I'm not sure about the gravy, but everything does like gravity. That is an excellent pun, Noel. You get points for your pun. Yeah. So, yes, ISS did do a dinner with the vegetables they grew on board. Okay, do we have any other questions out there? Because if not, I'm going to end this with the perfect number of viewers, which is 42. Now, admittedly, I'd love to see that up at more like 420. But it's folks like Skylius, who is live, who I can raid with the warning that her content is often mature, but often also related to astronomy. 420, it's a good number. It would allow us to make a partner. Yeah. So, yes. Oh, someone left. We're now at 41. Okay. Anyways, thank you all for being here. As always, this is a production of the Planetary Science Institute working in collaboration with Youngstown State University. We are here to put science in your brains. Give us a follow. Follows are free, and we'll let you know every time we go live to bring you the science. And, we are sustained by your subscriptions, your bits, your help on Patreon, wherever you can help us, even if it's just helping get people to rate us. Everything helps. So thank you for being here. I'm going to roll the credits, and then we're going to raid on over to Skylius. Please give her a warm and friendly hello and light up her chat with all the rockets you can find. So remember, wherever you are in the world, to have a fabulous morning, evening, or afternoon, and get outside and look up. Bye-bye.